Thank you, James. Hello, everyone. As James just said, I'm Melisa Camargo. I'm acting head of training services at Cambridge International. So I'm part of the professional development team in teaching and learning. And I'm very happy to be here today. So I'll be chairing this session with you. Thank you very much for joining us. It's an immense pleasure to have you all here. We hope you will enjoy this session. Just to explain how the session will work, I will kick us off with my takeaways from the keynote presentation, which I really enjoyed. Then I will invite you all to participate in an activity with the Mentimeter. We will post the link later on. Then I will pass on to 3 panelists who will be sharing tips for effective remote learning. So you will hear from Nivedita, who also works at Cambridge International, Claire, who is one of our trainers, and then Siti, a teacher from a Cambridge school in Malaysia. When they finish their presentations, it's your turn again. So we will be asking you to contribute with your tips as well, because we know you will have plenty to share. And then we'll finish off with questions and answers. Okay, so as James said, the chat is open for the whole session, so you don't need to wait to the end to ask your questions. And also, if you want a specific panelist to answer, please make sure you include that in your question, okay? So let's get started. I don't know about you, but I don't know about you, but I really enjoyed Rhonda's presentation. So I think she touched on very important points, and also reassured us about all the good things everyone has been doing. So yeah, I echo her words, and like everything everyone is doing is so great and so amazing. But the first point I really want to highlight from her presentation is about the different types of learner engagement that she mentioned. So I'm not teaching at the moment, but I do have a teaching background. And since the pandemic started, I've been reflecting a lot about what I would do and how I would be teaching and how it would be, what I would be creating with my students. And when she mentioned about the engagement, it was an eye-opener for me, because I think in an online environment, I would be mostly worried about their behavior and not so much about the affective and the cognitive that she mentioned. And it's interesting because in a face-to-face environment, like if I was in a room with my students, I would consider those. I may not name them as affective and cognitive, but I would think about it. But I don't know if I would in an online environment. And that's why that really caught my attention. The second point that I want to highlight is also kind of related to this first one, because it's when Rhonda said, excellent online teaching occurs because of the teacher's thinking. And I'm saying it's related to the first, because when she mentioned about the engagement, it really made me think about what I would be doing. And then I think after that, I would be thinking, what is it that I can really do to engage my learners? And that, of course, then would mean in terms of behavior, but also affectively and cognitively. So that was quite interesting for me. And that brings me to my third takeaway, which actually comes from her Q&A session and not from her presentation. And when we think again about teachers thinking and how to engage students, I really liked one of the questions that asked her about principles of good teaching, because the person mentioned, like, when you think about how to engage students, what you're going to do, planning, and etc., this is all good teaching in general. It's not just in an online environment. It's what you do in a face-to-face situation. So what's different? So what sort of thinking teachers should be doing when teaching in an online environment? And I think her answer was spot on. She said the difference is on how you use the technology. So the teacher's thinking being shifted to think about what we can do in an online environment that we could not do face-to-face. So in terms of using the technology to our benefit. So that was really interesting for me and a massive takeaway. So of course I could go on, and I could spend the whole hour talking about Rhonda's presentation, but that's not the point here. So I'm going to stop here so we can actually start our session. And again, a very warm welcome from us. Thank you very much for joining us. So, like I said, initially I would invite you to contribute in the Mentimeter. So we have a link and a code showing on the screen. Please click on the link. The link has also been shared in the chat. And type the code showing on the screen, please. So the question we are asking is, in your opinion, what words or phrases sum up good practice in remote teaching and learning? Oh, yeah, I can see engagement being the big one right in the middle, which is, of course, interesting. And I think Rhonda made her point. Communication, yeah, that's another interesting one. And I agree completely. Patience. I would say patience is a virtue of teachers that we have to have, right? Not only on an online environment, but yeah, it's really interesting that's there as one of the main words. Interactive. I do like a few of the little ones as well, like compassion, entertaining, differentiation, flexibility, yeah. Content delivery, of course, that's really important. Resourcefulness. But yeah, resourcefulness, I think we need to go back again to what Rhonda said, that sometimes it's best if we choose the simpler ones and the few resources as possible. Yeah, it's quite interesting that we have the word communication as a big one, and then we have a green one just below saying active communication. And that's interesting to think. What's the difference between them? I was wondering if any of the panelists would like to comment on the words, would like to come in at this point.
I like the little one in the corner that says questioning, because I think how we question online has also changed.
Thank you, Claire. Yeah, that's a really, really good one. I agree.
I would like to touch base about the active communication. I think that this is super vital as well, especially when we have Zoom and sometimes when students can't join. So you need to have another platform set up as well so that they can talk to you. If they can't join, how can we help, and so on.
Okay, thank you, Siti. Yeah, I think that's it. I think like everyone has contributed now. Yeah, it's really interesting to see like interactive, patience, communication, engagement, creativity. Yeah, this is really interesting to see like what are the words that we think about when we think about good practice in remote teaching and learning. Thank you very much everyone for contributing. So this is it from me now. So now I'm going to pass on to Nivedita. Thank you very much, everyone.
Hello. Hello, everyone. Nice to meet you and welcome to this session today. So I'll take on from where Melisa left. Just adding my 2 bits to what I found interesting in Rhonda's talk, were one thing that she started on a very positive note, in the sense that she said we should change the way we think about teaching and learning online, and we should use the appropriate language for that, because the appropriate language would, direct our behavior appropriately. So she said we should use words like online environment, going forward, next steps, etc. And also the second point that I noted was when she mentions that when children come back to school after the pandemic, we would find a wider range of differences in their performance in the class, and how do we address that? And for that, she suggested agile, excuse me, agile teachers thinking routine, which was called as CARS as an acronym. That really caught my attention, where C stands for clarity, A for access, R for relevance, and S for stretch. So I think as teachers, constantly in the classroom, we are thinking whether what we say is clear, whether everybody has understood it, whether it's relevant, and whether students are getting challenged enough. So these were the 2 points that I wanted to ask. Next slide, please. So I just put together a couple of slides, which I actually borrowed from a fellow maths trainer here at Cambridge International. And these are a few tips which I found would be very useful for science and maths teachers. So consistent structure and very clear and simple instructions makes it very easy for children to understand. Time management is again very important. So here is a small sample lesson that the teacher has designed, which breaks the lesson into clear parts with time given, and also with links to the relevant materials, with assessment, and also the support for students. So there are very clear instructions for students, what to do, how long to do. And last but not the least, don't be afraid to ask students for their feedback on the sessions. And this can be done by using Google Forms or any other mode of communication that you have with the children, whether it's using Zoom, Google Meet, whatever platform. And again, going back to what Melisa said earlier about Rhonda's talk, where she said that choose simple. Don't make things too complicated by choosing too many resources, too many online platforms. Just a few, but the ones which are more effective for your teaching and learning. Next slide, please. Thank you. Another resource which I found would be very useful for teachers is our online page on teaching and learning in COVID times, where we have different resources for when schools are completely moving on to virtual teaching and learning, and then again coming back to when after the pandemic, when children come come back to the classroom, how to detect the learning gaps, how to address, how to look after the emotional and mental well-being of children. You would find a whole lot of resources on our website to support your teaching and learning in the current environment, and also for generic teaching and learning. So we have resources like Getting Started With, which include a number of topics like active learning, assessment for learning, metacognition, effective questioning, etc. Apart from that, we have education briefs, which would also make very interesting reading for teachers who are constantly wanting to update themselves and upgrade themselves professionally. Next slide, please. And this is a slide which I have listed some resources which could be useful for maths and science teachers. You may have already used them, but I thought it would be good to compile them at one place. So with that, I come to the end of my bit, and I pass on to our next panelist, Claire Roper. Over to you, Claire. Thanks.
Thank you. Welcome everybody. It's lovely to be here. I also really enjoyed Rhonda's talk, and in the beginning she thanked us as teachers about what we've been doing during the pandemic. But for me, it's actually been an exciting opportunity to try all sorts of new things, and also an honour. I think as science teachers, our subject, science, has been such in the highlight during the pandemic as to how important it is in terms of solving problems. And the opportunity we have to inspire the next generation of scientists is really something that I engage with a lot, and really find something that has quite a lot of prestige, if you like, about it. So I've enjoyed, as Melisa said, not only thinking about what I might do, but also being able to use my classes as experiments themselves, and receiving feedback from them about what I've been doing. Next slide. So she talked to us about a frame that she used when she was doing her learning, and she called it a tic-tac-toe, and she had a diagram, you might remember, where we used a scaffold to identify different letters onto words. And that resonated a lot with me, because she said that learning is a consequence of thinking. It was a quote she had taken from one of her colleagues, David Perkins. And I've been using that in a slightly different way, using what we call thinking maps. So thinking maps are a visual scaffold that can be used to look at higher order thinking processes. And there are actually 8 different maps. Each one is linked to a specific thought process. And on this slide, I've shown 3 of those maps. The first one on the left is called a circle map. And we use that for describing skills, which are quite common in science. For instance, you could put the word transition elements in the middle circle, and then ask your students to fill around the outer circle with all the words that would describe transition elements. So they could add words like catalyst or high density and so on. The middle frame is one that's used for categorizing things. And so I've just taken a snapshot actually of the middle of one of those maps. It's called a brace map. And the first line, which is not shown on the left-hand side, could have a word like an atom on it. And then you would ask the students to break that down into its subparts. So the top line could be the nucleus, and then the one underneath an electron shell, and so on, into its subparts. I really like these because they're able to differentiate learning with your students, because you could give them just the instruction, please make a brace map, to break down the atom into its subparts, or you could give them a scaffolded brace map with the right number of levels and break down parts inside it, or just to tell them that it should be broken down into 3 different levels. The map on the right-hand side is used for evaluations. So it's called a double bubble map, which I think is quite a fun name. I've shown one with an example where we're comparing veins and arteries. So the middle set of bubbles is where you would put the similarities between the 2. And then on the left-hand side, things only to do with veins, and on the right-hand side, features only to do with arteries. And when Rhonda was doing the Q&A session, one of the questions that came up was, should we have our cameras on or cameras off when we are doing our lessons? And her answer was that if we could actually see them learning, sometimes it's not so important to have our cameras on as to be able to see their engagement. And I found that when I've been doing thinking maps with my classes online, I've been able to see their thinking. Melisa, you said in the beginning about us being able to actually think about engagement, not just on behavioural side, but in terms of the cognitive side. And this has really been a useful opportunity to look at cognitive learning actually online. On the next slide, I've got some examples of that that have been done by my classes. So if we can move on to that slide, I can show you some examples. I've particularly taken really small screenshots here, so I'm not expecting that you'll be able to see what my students have written, but on the top left-hand side were 2 breakout rooms where one group of students was deciding together about the steps that were needed in genetic engineering, and the breakout room 5 was doing the same task, but they decided to use a different flow map. So a flow map is another thinking map, and it's used for sequencing, which is also really useful in science. And the multi-flow map that the students in room 5 has shown really gave us lots of discussion points about whether those should be a multi-flow map, 2 things coming into one, or whether it was just a single linear sequence of events. And so they were able to work together and then discuss each other's thinking now that they had put it into a scaffold, a frame of their thoughts. The one on the bottom right-hand corner is actually using the veins, arteries, but this time capillaries as well. And that's a Venn diagram where you can put the similarities in the middle and then the differences and similarities between all the 3 features in the different boxes. This was taken midway through one of the sessions, and so you can see that the students haven't filled in blocks in all of the squares yet, circles yet. The one that's in blue is another multi-flow map. These are really, really good about looking at causes and consequences. So my students here were looking at the human influences on the environment and how they're interlinked with each other. Again, you can see that it's a very structured map, and that's what's really useful about using thinking maps, is that you scaffold and really think about what it is that they're going to have on their map. And that means you don't land up with all sorts of different kinds of bats if you've really framed that question that is in the thinking map itself. And on the bottom left is a little small video. I don't know if we can pop to the video itself or not, but you can see my students actually working here. Their cursors are moving around on the screen, and they're able to move the different blocks and add new ones and change ones around. This is the view from my screen sitting at home, and so I'm able to see all 4 groups working at different places along, and also which students are moving which blocks. That's using an online collaborative platform to make the thinking maps, and it's certainly something that I'm going to take back with me into the classroom. Whereas we might have done something before where I'd put my students on a table and they would all use a big piece of paper, now when they can do it online like that, they're less reluctant to make mistakes, because it's not actually something that they would then have to rub out or change. They can simply move steps around or move different blocks or edit them. And so they're much more engaged actually in terms of the cognitive processes in the learning. And so that's one of the tools that has actually come out of lockdown that I'm going to take back to the classroom with me. And with that, I'm going to pass on to Siti Zaleha, who is going to tell you some things that she's discovered.
Thank you, Claire. Hello, everyone. My name is Siti Zaleha. I'm a secondary maths teacher as well as Cambridge trainer and examiner, and I'm from Malaysia. Next slide, please. So what I would like to share with you today about the tips for remote teaching and learning is about how to elicit and gain student engagement in mathematics. I have been teaching online and hybrid for the past 1.5 years, and I've tried and tested many different online platforms, because my key concern at that time is how do I maintain and deliver some of the key features and the transferability factors that I usually had in my physical classroom into online classroom. So that was my primary focus at that time. And throughout the time when I tested and reflected on some parts, and after listening to the Q&A session by Dr. Rhonda, I echo what she said, and this has been shared as well by Nivedita as well as Claire about the engagement, because this is something that we don't really particularly plan for when we teach in the classroom. Because we know if we do group work, this is the kinds of engagement that we can observe, see, and participate. If we do pair work, if we do different activities. But now, since we can't do it, and we need to be making sure that there are certain types of engagement that are visible, then that is somehow, and majority of our focus now is about making sure that we get those engagement when doing online classroom. So this is what I want to highlight as well, the importance of setting the right target of what kind of engagement that we would like to elicit and gain from our students, and then we try to match it with the available online platform tools. I think that this has to be made visible, and as well to echo many times over, because if we don't set the correct intention, we won't be making sure that the tool that we are using can complement and help us to make the best use of the functions to make sure that our students can engage better. So when we talk about student engagement, I always follow this ABC rule. There are 3 types of it: affective, behavioral, and cognitive. And I've tried many online platforms for learning, and Neopod seemed to be the best one and the most frequently used for me. Because when you teach maths, there are so many different strands. There are numbers where you must make sure that the students write down the workings. You can see step by step. Algebra, it's abstract. How do we get those abstract contextual thinking being made visible online? Geometry, they need to draw, they need to sketch, they need to tell you what parallel lines, angles are, and so on, as well as statistics. So to make learning visible cognitively, Neopod seems to be the best option for me, because you can upload your slides, and in between, you can add on any types of formative assessment that you want at that particular stop from your progression in your slides. For example, there's this whiteboard function where I can just ask my year 7s, draw all types of triangles that you know. Then you can see from there whether what they said about listing down the triangles is equal to what they can sketch with the features, like, you know, all 3 dashes for equilateral triangles, and then the small square for right angle triangle, and so on. And the best part about using Neopod is at the end of it, you will be provided with a report. You can have all the students' work, the statistics, all the poll, all the feedback from the beginning at the end of the lesson that you did. And usually I link this very tight with how to gain effective engagement, because there are quiet students, there are those reserved ones who will never participate, but they will contact you directly via Hangout or private chat on Zoom. So how do we make these students a part of our whole classroom community? So basically, Neopod helped me in the sense that when I have students work, I will plan for another simple classroom whereby I reflect on what we did on Neopod, and I pick and choose specifically the work of these quiet and reserved learners. And this is when I will show it to everyone, and I will highlight their contributions in the classroom, even though they are not frequently contributed in terms of speaking or you know, talking to each other. But this is how I encourage them to also take part and engage in the online lesson. Behavioral is about setting up routines, communication with parents, and so many other parts that we can actually do frequently in the classroom. Next slide, please. So to echo again what Dr. Rhonda said about you know, the issue of camera on or camera off, is not to think about why do we need it on and off, because students may nod and seem to be sharing their confidence with you, like, hey, I understand this, miss, and so on, but we don't really know it, right? So Instead, she said, think about what kind of engagement do I want to see? What are the tools I have to ensure that I receive that kind of engagement? This way, we will be more successful and students will engage purposefully in the online lesson. Next slide, please. And I will talk about this more by sharing snippets of what I did in my online classroom with the tools that I explained in my breakout session next week about practical and stress-free strategies in supporting student engagement online. Pretty much that's about my sharing. Handing over to Melisa. Thank you.
Thank you very much, CT, and thank you to Claire and Nivedita. I can see a few questions coming up already, and I've learned a lot as well, so really, really interesting. Thank you very much. So, like I said at the beginning, after the presentations, we would hand over to the participants again, and we would like you to share your tips for remote or blended learning. So there is a link that has been posted on the chat box. So please access that link and share your tips with us, and I'll be commenting on a few of them, and I will invite Claire, Nivedita, and CT to join us as well on commenting on it. Thank you. If you have never used the Padlet before, you can see that there is a plus sign at the bottom right. So you just need to click on it so you can add your practical tips. We can see a few things coming in, which is quite interesting. Short videos from YouTube, yes, I think that's a really good idea. Online games. Oh yeah, there's a good tip here for a Chrome extension for a Breakout Room on Google Meet if you don't have access to that feature. I'm going to wait a little bit more.
Melisa, can I pick up the one about FIT? FIT is a brilliant resource for us in science. There are lots of experiments that you can do as simulations on FIT, which enable you to allow students to actually change variables and see the outcome and collect data. And they've got resources for biology, chemistry, and physics. So if you haven't used FIT before, that's definitely a really useful source. That's PHET. It's up on the Padlet somewhere, but it keeps moving around to where it is. FIT simulations.
It's this one at the top here, right? FET, P-H-E-T.
That's right.
Someone posted, yeah, someone posted it. I use FET simulations for some topics. Yeah.
Yes.
Thank you, Claire. Yeah, someone mentioned as well about students with social anxiety. And I think that's something really interesting and something really important for us to think about as well. I know we are talking about practical things right now, but I think sometimes we are so worried about what students have missed with the online environment and not being in school. But for some students, moving to an online environment was such a good thing, and they feel now much more comfortable to contribute and to participate. So I think we need sometimes to think about the positives as well. Yeah, there's a lot of good things here, like mini bite sessions. Desmos for mathematics. It's all, yeah, grade 2. Neopod. Yeah, there are more than once we have people saying group work, community. So it would be nice if you could give a little bit more detail about that. How do you do that group work? How do you encourage the sense of community? Mind mapping, Claire touched on that as well. CT, Nivedita, do you want to comment on anything as well?
Very interesting comments here and very useful tips. I am also very keen to listen more on the social anxiety and the well-being of children, because I think there's been a mixed response. For some children, moving to online has been good in terms of their performance, in terms of their participation. But for others, I think it has also led to some kind of emotional and mental health problems, because there are students who thrive in a physical classroom with their friends in front of the teachers, and for them to get locked in the house only with a screen, what effect has it had? So anybody would like to share anything on the emotional or mental well-being?
Thank you, Nivedita.
Melise, if I could add on that as well. Because my school is an all-inclusive school, so we also have students with learning difficulties and specific disabilities that we also need to cater. And of course, I find that private chat, hangout really helped during online lessons as well, because some students, they really choose not to participate even in physical classrooms, but actually more communications have been going on when I started teaching online, because these students find it more safe that they can contribute and communicate with me when they have their own like separate mode of communication with private chat and all.
Thank you, CT. That's definitely a good point. Thank you.
Melisa, I also saw somebody there talked about using Flipgrid. Flipgrid's really great for doing little videos of your students. They make their videos and then they upload them onto Flipgrid. And that I've actually used when they've been doing experiments at home. And next week, I'll be doing a session with another colleague and we'll be talking about doing science practicals from home and how to think about that. And so certainly Flipgrid is definitely one of the things that I've used in that context.
Thank you, Claire. Yeah, we'll post the link to Claire's breakout room. Breakout room. I'm so used to the online environment now that comes automatically. So to the breakout next week for the conference. But you can also access all the program in the Cambridge International main website. Yeah, so really, really good tips here. So we have Jamboard as well, quizzes, digital quizzes. I read one about like doing the practical, like dividing, like someone writes the introduction and then moves to another student who writes the experiment, and then the other write the conclusion. So that's quite interesting on how to do cooperation. Yeah, that's really good. You will have access to this Padlet later as well. So if you want then to come back and read everything that everyone posted and get some ideas from there, this Padlet will be available. Okay, so that's why we wanted to be able to record the tips here as well, so everyone can use later on.
I just also wanted to add for science and maths teachers to look for Resource Plus, our free resource on our website, which is normally charged. And now we also have a special edition for learners to use. So do check, because there are a number of virtual experiments and associated connected activities there, which are available for your students and you to use in your classrooms.
Yeah, are you talking about Resource Plus, Nivette?
Yes, I'm talking about Resource Plus.
Yeah, yeah. So Resource Plus is available free of charge. Yeah, now for everyone. Thank you very much. So yes, please keep contributing. This is really interesting, and you got that list from Nivette from her presentation. Claire has shared some tips. CT also contributed a lot. So we will have these the slides will be shared later. Okay, so you will have access to everything. Thank you very much. So now we're going to move to the questions. So please use the chat box to ask your questions. I can see there are a few of them. I just want to comment on Louise's comment here about the limit chat room use in her region. I'm not sure in which region she is, but she's saying that it's quite hard for them sometimes to have the cameras on or the audio on. So they need to use the chat room, and that has been really useful. So I think, yeah, I think it's again goes back to what Rhonda said. It's making good use of the technology and making it simple. Okay, thank you very much. So I'm going to pick up some questions now, and I will choose some of the panelists to answer. So I'm going to start with this one that says, not all of our learners have access to computers, and many join in from smartphones. So do you think using apps like Miro or Neopod will work on handheld devices? So I think I'm going to pass that on to Claire first, who actually presented Miro. But then all the other panelists, if you want to give your opinion as well on that, you're welcome.
Yeah, thank you for the question, Melisa. You're absolutely right. Most students definitely have a mobile phone or a handheld device, and that is sometimes their best link with the class environment if they're remote. You can use quite a lot of these tools online. The biggest problem really is the size of their screen. My students that have used their mobile phones to connect with me using Miro or Lucid Chart to do the thinking maps I was showing you, have told me that their experience is fine, and they're quite adept at using their thumbs and fingers to move around on the screen, but just that it is quite small for them. If that's the case, the key thing is to make sure that they're able to know exactly where in the window you are and what questions that you're wanting them to answer, so that they can focus in and zoom into that area of the screen.
Thank you, Claire. I have another question here, and I think I'm going to ask Siti that one. Yuwanga, I'm sorry if I'm not pronouncing your name correctly, but she or he is asking that they would like some suggestions from teachers about how you work with structured questions with the students online. So do you have anything to share, Siti?
Oh, okay. Thank you, Melisa. When it comes to structured questions, I would say that it depends on how you want to work on it. I mean, in terms of the flow, we can always have like the 3 tiers that we always do, like, you know, bronze, silver, and gold. But in terms of how we deliver it to students, it depends. For example, if you are using Google Form, I find that it's quite useful as well, because you can have like different types of questions. You can have like multiple choice in the beginning, you can have like fill in the blanks, and you can also set for them to upload a snapshot of their workings to complement some of the more challenging questions. So I think that's one of the approach of how we can actually structure the questions and deliver it to the students, so that we can have like a multiple responses in terms of different difficulties of the questions, and we also put emphasize more on which one that needs to be shown working, which one that needs to be explained. Like we can also offer like the wrong and correct statements and ask them to explain if we want to check their conceptual understanding. So this is some of the things, and I will explain more later in my breakout session next week. Thank you.
Thank you, Sid. And I think that in a way answers Hillary's question about questions about like show your working. So I think it's you already answered that question. But if you want to add anything else, feel free to do so.
I just want to add one. If you use Neopod, that's quite interesting as well, because as you teach one particular concept or topic, and you want to see whether, for example, Pythagoras, a squared plus b squared equals c squared, students will say, yes, 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 we know this, we know the formula, okay. When you give a question, there's this function on Neopod whereby you can activate their online whiteboard. So on your screen, you will see 25 whiteboards working on that same question on one go, at one go, and you can pick and choose, and at the same time you can also offer formative feedback, real-time formative feedback, just by telling these students, oh, you haven't like square rooted this part, oh, you have to give it until 3 significant figures. So Neopod allows you to actually take part when students are working, and you can see and you can also show some good examples as a standard, so that most students know what they should be working on and how to organize their workings in an orderly manner. Thank you.
Thank you, Siti. That's really, really helpful.
Melisa, Melisa, can I just add there that there's another resource called Whiteboard FI. I'll just put the link in the chat now. That one is similar to what you're describing, Siti, where the students can write on their screen, and that works very well on a mobile phone. And so they can write their working, and you on your screen see all the little whiteboards as if they were using mini whiteboards in the classroom and then holding them up for you. And they can't see each other's. So it's very much that they do their own independent work and are able to then show some working.
Thank you, Claire. Misha also suggested this website, I think it's drfrostmaths.com, that requires students to show their working when they solve the question. So yeah, I think we have loads of different options here that we can use. Thank you. Claire, if you want to stay on the line, I have a question for you as well. So how can scientific lab experiments be compensated for the sake of students as for videos when videos are not sufficient substitution?
Yeah, I think that's definitely been something that we've spoken about a lot amongst us as science teachers around the world, because doing lab experiments is something where you would think that you absolutely need the classroom environment. And I agree that videos aren't a substitution for students doing their own experiments. And as I mentioned before, I think the best thing to do is to come along next week, because we will be doing a session particularly about practical work and how to engage with that. But just as a snapshot, you can do experiments at home. There are things that you need to consider so that the students are doing them safely, and also that you're able to really understand their outcomes. And there are also other resources that you can use to allow them to do various aspects of the experiment. Karen Strauss has had students where they've been working at home and then videoing them to the students the students in the lab, videoing what they're doing to the students at home so that they can participate that way. There's also a lot of fantastic data that's on a website called CODAP. I'll also put that link in the chat in a moment, where you can have data sets that they can engage with and link and move around the data on the screen. So although they haven't collected the data themselves, they need to do a lot of the processing and evaluating of it.
Nivedita, do you want to add anything here?
Not much, Melisa. I think I agree with Claire. It's difficult to carry experiments in an online setting, but we can encourage. So we have to look for simpler activities, what children can do. At the most, we can give them some demonstrations. But I think in the absence of physical classroom, the PhET and the resource plus virtual experiments which are available online, those are the best bets. And those coupled with a lot of discussions, probably, I'm a chemistry teacher, and chemistry teaching has always been abstract. So you need to take them through that process, probably by discussion. That is the best we can do in this particular situation, unfortunately. But I still feel something is better than nothing, The simulations and the virtual experiments which are available to us would go a long way to help children, rather than, absolutely no practicals in science.
Thank you, Nivedita. Thank you. Yeah, Newport has been mentioned as the way to go, apparently, but yeah, it needs to be used for your own situation, like for your environment, what works for you and your learners. So it goes back to that teacher's thinking and choosing the best tool to use. Yeah, we have a lot of suggestions here now. Everyone is contributing, which is really nice. Most of the questions, they are about like practicals in science. So again, come to Claire's breakout next week. You're going to get a lot from there. For mathematics, people are asking if there is anything specific for mathematics. I know about for geometry. I don't know if you ever use GeoGebra. It is really nice to show students how dynamic geometry can be. And I think GeoGebra is a very good example of what Rhonda's mentioned as well. That's like using the technology to do things you wouldn't be able to do in the classroom. And GeoGebra is, it's quite interesting because if you move, for example, one of the points of a figure, like one of the shapes, the shape will move accordingly. So it's really, really nice, and it's something that can be used a lot for geometry in general. Yeah, I mentioned GeoGebra. I've never used Desmos before, but I've heard about it, and a lot of maths teachers mentioning about Desmos, so I believe it is a good tool as well. Yeah, Enreach, absolutely. Someone just mentioned about Enreach. They have like really, really good problems, and now they have moved to live problems as well. It's really nice, and you have for all ages, and they do make like students think mathematically, and helps a lot. Yeah, Enreach is definitely a good one. Yeah, GeoGebra is what Uzma posted here. That's how you spell it. That's correct. Do we have any other questions or anything else that the panelists want to comment on or share? Yes, we will share the recording of the video. I just saw a question here. Absolutely. Yeah.
I just wanted to ask or just make a comment if somebody would like to share. We still have 2-3 minutes. So basically, what we have discussed is generic and it's applicable to children of higher classes. Any special tips for those who are just coming into the lower secondary? I mean, grade 6, 7, 8 for sciences and maths. Would any of the panelists want to add something, or any of the participants would want to share something on the lower grades in science and maths?
My younger students have really liked taking short little video clips of themselves. I think younger students are so familiar with technology these days and how they use it in social media that they actually engage with it much more easily than sometimes we do. I've asked them to take little videos using Flipgrid of their projects, of what their thoughts are, and that's sort of freed them from the idea of needing to always write everything down. But it's also made them think quite carefully about what they say and what they show, because though you can limit the length of time that their video can be.
Thank you, Claire. CT? Or is it Nivedita? Sorry.
Thanks,
Yeah,
Claire. That was useful. Yes, CT, please go on.
So you are talking about the videos.
Yes.
I would say like lower secondary, they're really good in this, because in my school we have green screen as well. Projects can be done, and they are super like tech when it comes to all this. Older students, they pretty much rather do something that requires them to be more inquisitive and technical when it comes to the subject knowledge. So yeah.
Thank you, City. Yeah, I think like a lot of the tips and the tools that were shared here today, they apply to a lot of the ages, like to most of the ages. So it's just making sure you are thinking about their engagement and how students are behaving, and also the affective and the cognitive one. But yeah, and I think like teachers, we know our students, so it's just like considering that as well when planning and choosing the tools. Okay, thank you very much. So yeah, unfortunately, I'm afraid we're running out of time. I would like to finish off thanking our panelists for all their tips and what they shared with us, and also everyone that joined us today. Thank you very much for your contributions and your really good questions. So I hope you enjoyed the session as much as I did. So thank you very much, everyone, for joining us, and I wish you all the best. Thank you very much.